I'm Jack Pauler. I am founder and principal analyst of Paradigm Technica, and I'm going to talk to you about FIDO. So with computers, we're really concerned about two things, authentication and authorization. And for passwords and passwordless, we're really concerned about authentication, which is really, are you who you say you are? And so we've all seen, go show your ID at TSA or go log in, do a password and username. That's what we've been doing forever. So if you think about passwords, we started using passwords when we started doing the computers back 50, 60, 70 years ago, but passwords have been around since the ancient times. They're how you protected people getting into your castle. You want to knock on the door, say, what's the secret word? If you got the secret word, said, yes, you're somebody we approve, you can get in, yada, yada, yada. Passwords really stink, right? Passwords stink because it's a shared secret between people or between you and the computer, and somebody can steal that secret. In particular, humans are really gullible, right? And so it's very easy to get somebody to give up their password, as in phishing emails, right? So we call all of these attempts, started with phishing, which is emails. We now have smishing, which is on your text. There's vishing, which is a video version, right? We now use AI to convince people to, we use deep fakes of audio and video to convince people to give up their credentials, their shared secrets. We put a Band-Aid around this called MFA, multi-factor authentication. So passwords is basically a secret, something you know. And we said, well, if we can convince you to give up something you know, let's start with something you know and something you have, like a cell phone, or something you are, like a biometrics. But it's still a shared secret between you and the server. And as I said, humans are gullible, right? Everybody knows that three-card money is a scam, but people continue to play three-card money because they think they're smarter than the average bear and they're going to out-scam the scammers, right? And that just doesn't happen. So the identity industry said, let's go to something that's new technology, but isn't really new, but we know works. And that's public key cryptography. So public key cryptography is new for identity and access and authorization, but has been around since the 1970s. And it's basically fancy math that says, I have a one-way to encrypt. I have a one-way function that can encrypt or decrypt something. So I can create a private key to encrypt something and a public key to decrypt it. And I can't go backwards using the same key. I can't take my public key, encrypt the thing, and then decrypt the thing at the same time. So it makes it much more secure. And it's also a way I can share a key and share a secret that nobody can use to decrypt my technology. In computers, we're using this with a coprocessor called a trusted processor module. It's your security coprocessor. And it does 3 or 4 things. The most important thing it does is it's a secure vault. When you put your keys in this, it's a one-way vault. You can never extract the key. So if somebody puts a gun to your head and says, give me the keys, extract the keys out of the vault, it can't happen. It's impossible. It's physically impossible to do. The second thing the TPM does is it actually does the encryption and decryption for you. So rather than saying, give me the key and let me run the encryption algorithm, you say, here's my text, send it to the processor and use the encryption with this particular key to encrypt it and give it back to me. Now, the important thing about this is we want to protect access to this secure vault so nobody else can do this function. And we do that by protecting it with a PIN or biometrics, your face print or your voice palm print or your fingerprint. Now this is secure because that security is never shared. The encoding of your fingerprints or your face or everything else is stored in the vault. So it's never shared with anybody else in that vault. If you use a different computer, you're not sharing your biometrics, you're re-encoding and recapturing the data and putting it in a new key, in a new vault. So the important thing here, like I said, is it's not shared. When you look at some things like this is Panera, who has partnered with Amazon One to use Amazon Palm Reader. The problem with this type of technology is your biometric data isn't stored on that device. It's stored in the cloud, which means somebody can steal it. Now, that's not a knock on Amazon, and I'm not saying Amazon security isn't good. That's just the architecture. because it's stored and shared somewhere else, it's accessible and somebody can get to it and steal it at some point. So you got to differentiate between what's stored in the secure module on your computer or your cell phone versus what's shared in the cloud. So let's see how this works in FIDO. When you go to log into the website, you hand your username to the website, and the website basically says, let's send a challenge back to your computer. It says, here's a string, tech field day, that we're going to ask you to encrypt with your private key. So you then send that string, tech field day, to your private vault and say, encrypt it. That uses your private keys. Now, specifically here, it's the private key for that particular web server with that particular URL. So nobody can masquerade as a different web server and convince this to happen. It's all very secure and protected that way. So the TPM uses your private key to encrypt the string and gives you back Big Latin ec field day te, right? And then you send that to the web server. And the web server then goes to its secure module and says, decrypt it using the public key for that particular user. And then it says, did they match? If they match, you are now authenticated. You are who you say you are. And you now get, I'm authenticated and I can use the service. So that is FIDO in a nutshell. Now we call this phishing resistant, not phishing proof. Architecturally, we believe there is no way to get around this. There's no way to socially engineer or convince a gullible human to give up their access. Now, there are still ways to get access to this. For instance, if I put a gun to your head and say, put your finger on the fingerprint reader so that I unlock it, then yes, people can get around it. But from an architectural perspective where we say, is there a way for a bad guy to jump in the middle of the conversation and convince you to give up your secrets one way or another? That can't happen. So this is a very secure way and eliminates the problems of passwords. Now, if we go back and we think about passwords, passwords have a couple of big problems. Simple passwords are easy to break and easy to copy. Complex passwords are hard for people to remember. So what people typically do is they use the same password on multiple sites. Once one site gets broken, then that username and password and email gets bombarded on a whole bunch of other sites, and people break into multiple accounts and do credential theft that way. So when you see something that says, hey, 10 million accounts were stolen, the problem isn't that particular service that got broken, it's all the others that will then get broken because people reuse their passwords. This is why your corporations say, let's change your passwords very frequently, but then that becomes a pain in the butt, and all of this becomes very complex and hard to manage passwords. So when you see a site offer you a passkey, I really want to convince you to do that because it's going to make it much, much more secure for you and for the internet as a whole. So that is FIDO in a nutshell. I'm Jack Pollard. I'm Principal Analyst with Paradigm Technica. You can find me on LinkedIn or social media as @Pollard. Thank you.